Good morning, everybody. Hopefully the quiz went good yesterday. I haven't got to grade them yet, but I'm hoping to have them graded by tomorrow when I come back. Please don't worry. We'll fix whatever we have to fix when I get back. I know this week has not been ideal, but it sounds like you guys have been working hard, and I'm really proud of you. Today and tomorrow is going to be about angles. So we've spent a lot of time talking about segments and midpoints, so we're going to shift gears and talk about angles now. And before we can do that, we have a few vocabulary words to talk about. So the first one is ray, and we know a ray is part of a line with one endpoint extending forever in one direction. And the thing with rays is that we know order matters when we're dealing with a ray. So in the picture, like this ray starts at M and goes to the right. So we could call this ray MP, or we could call this ray MO. They both start at M and go to the right. The next word is opposite rays. So these are two rays that share a common endpoint and go in opposite directions. And the big thing with opposite rays is they form a line. So in the picture, like I would have the ray that starts at J and goes to the left, and the ray that starts at J and goes to the right. So JH and JK would be opposite rays. And then the last word, interior versus exterior, is exactly what it sounds like. So inside the angle would be the interior. Anything outside the angle would be the exterior. So that's just differentiating between inside the angle or outside the angle. All right, so now talking about angles. So an angle is formed by two rays with a common endpoint. So two rays with a common endpoint. The common endpoint is called the vertex. So if I look in this picture, where these two rays come together would be B. So B is the vertex of that angle. The rays are called the sides. Now here's the thing a lot of students mess up on. They want to say a side is A, but A is not a side. It is the ray BA. So BA would be a side, and then BC would be a side. So those would be the sides of that angle. Notice they both start with the vertex. They both start with B. You can name an angle using three letters, and the middle letter must be the vertex. So like I can start at this top point up here, start at A, and I can call this angle ABC, or I can reverse that and call it angle CBA. The important thing is that the vertex is the middle letter in both names. If there's only one angle in the picture, we can use a shortcut and just name it by its vertex, so we could call it angle B. So those are the ways to name it. We talked about its sides, talked about its vertex. All right, there are four types of angles. So the first angle is the small one, and we call that the acute angle. And acute angles are going to be anything less than 90. All right, the next one is the big angle. That is the obtuse angle. And the obtuse angle is anything bigger than 90. All right, the next one is marked with this little box. That's how we know that that one is the right angle. And a right angle is exactly 90 degrees. So the right angle is exactly 90. And then the last one, we notice it's a straight line, and it is literally called the straight angle. So it's named just like what it looks like. And it is exactly 180 degrees. So those are the four types of angles that we're going to talk about. All right, so now we're going to look at example 1. So the first question is name the vertex. So the vertex is the corner. So that would be our point K. The sides again are the rays. So J is not a side, but KJ is a side. So KJ is a side. And then the other side would be KL. So that would be my other side. And then we're going to name it. So we can name it with three letters, and we do it in order. So I could call it JKL, so angle JKL. I could turn it around and LKJ, so LKJ. And then the last way is just to name it by its vertex. Now remember, using three letters, that middle letter is the vertex. It's where it like makes its turn. And then if I classify the angle, that's going to be your acute, obtuse, right, or straight. This angle is bigger than 90, so that's going to make this angle the obtuse angle. All right, let's try that one more time. So on example 2, the vertex is where everything comes together, so that's going to be your point S. The sides are going to be the rays, so it is not just R, it is ray SR. And it is not just T, it is ray ST. So those are the sides of the angle. When we name it, again, we name it just like it looks. We're going to draw it out. So angle RST, where S is in the middle. We turn it around, angle TSR. And then the last one would be just angle S. So we would name it by its vertex. And then this nice little box here lets you know that that is a right angle. All right, for this example, we have to measure the angle using this protractor. That's what we call that little thing off to the right. And then we have to classify it based on that measure. So the first angle is angle MLN. That means I start at M, I go to L, and I go up to N. And I have to figure out how big that is. So from here to here, I can see that that is going to be 60 degrees. So this angle is 60 degrees. And since that is less than 90, that makes that angle acute. All right, the next one is NLP. So that means we're going to start at N, go down to L, and up to P. So now I need to know how wide this one is. This one's a little trickier. I see this one's at 130, and I see this one's at 60. So I'm going to subtract those two numbers, and I'm going to get 70. Again, that is less than 90, so this is still an acute angle. All right, the next one is angle NLQ. So we need to know what this measurement is. So that is 180 minus 60, which gives us a total of 120. Since that one's bigger than 90, that angle is going to be obtuse. All right, looking at the next one, we have angle OLP. So now we're looking at this space. So that tells us to take 130 minus 90, and we should get 40. So again, that angle is less than 90, so that makes it acute. Now we have angle MLQ. Now notice this one goes straight across, so that one's just going to be 180 degrees. And that makes this one a straight angle. So that's that weird one. That's the straight angle. All right, now we're looking at NLO. So we've got 90 minus 60, which is just going to be 30. And again, that's just acute. So almost done with these. The next one is MLP. So that one would be from 0 to 130. So that one is just 130 degrees, which is obtuse. And the last one of these is OLQ, which 180 minus 90 tells you that that angle is 90, and that would make this angle a right angle. So the biggest thing with this section is just figuring out where the two spots are. So like you're looking at the first letter basically and the last letter, and then you're figuring out the distance between those two letters. All right, angle addition basically is just saying that this angle here plus this angle here would give you the whole angle. So like when I look at example 1, it says angle ABD is 48, and it says angle DBC is 78, and it wants to know what the whole angle is. So I would just add those two numbers together and I would get 126. Now the next one is a little different. It's telling you that angle DBC is 74, but angle ABC, the whole angle, is 119. So on that one, we wouldn't add those, we're going to subtract those. 119 minus 74 gives me 45. All right, so now let's look at number 13. So number 13 says angle PQR, so PQR, the whole angle, is 141 degrees. That means this top piece plus this bottom piece has to give me 141. So I'm going to write the equation literally 13x plus 4 plus the bottom piece 10x minus 1 has to equal 141. So from here we're just going to solve. So we're going to combine our like terms. So we have 23 x's. 4 minus 1 is 3 equals 141. When I subtract 3 from both sides, we get 23x equals 138, and then divide, we get x equals 6. So that's our first part. Now it says we have to plug it back in. So when I plug it back in for PQS, so PQS, that's that top angle, we would have 13 times 6 plus 4, which gives me 82. And then I plug it into the bottom, we would have 10 times 6 minus 1, which gives me 59. All right, Angle bisector is very similar to a segment bisector. So we know a segment bisector just cuts a segment in half, and that's essentially what an angle bisector does. It is a ray that divides an angle into two congruent angles. And as I said, it simply cuts the angle in half, so it makes the two sides exactly the same. So in this particular picture, this ray in the middle, ray BD, is the angle bisector. Therefore, the top part and the bottom part have to be equal. So that would be angle ABD is congruent to the bottom angle, so CBD. All right, so looking at the last example, it says XY bisects angle WXZ. So that means each of these sides are going to be equal to each other. So that's how we set up the equation. 7x minus 7 equals 5x plus 3. It's been bisected, it's cut in half, they're equal to each other. Subtract 5x, and then add your 7, you get 2x equals 10. So x is going to be 5, all right? Now it says we have to find angle WXY, WXY. So we got to find the one to the left. So that's going to be 7 times 5 minus 7, which gives me 28. Now we're going to find the other side. So 5 times 5 plus 3, again, that's 28. And then the last one wants angle WXZ, so it wants the whole angle. So that means we're going to add the two pieces together, and we're going to get 56. I know that lesson was a little bit longer than the last couple times that we've done this, and hopefully you made it through it and it wasn't too bad.